Ahoy, hoy, Mr. Nickerson here, and we're going to go over 7.4 tonight. Please pull out the notes you received in class. We'll get started. Alright, let's get started. So, looking at the first example, we got 5x plus 2y equals 16, and 3x minus 4y equals 20. And right now, the three methods we've learned, by graphing, substitution, or just plain elimination by adding, wouldn't work for this problem. If we graph this one, we'd be dealing with y-intercepts that are fractions, and that's not our priority. If we can avoid that, we probably should. For substitution, that wouldn't be the easiest method either, because if we solve for any of the variables, x or y, it'll result in a fraction. So that's probably not our best choice. If we just did elimination like we learned in 7.3 and did addition, well, nothing would eliminate. We'd make a third equation, and that wouldn't help us at all either. So there's another style of elimination, and that's what we'll learn about today. So let's take a look. Example 1 is the same example that's in big font there. And let's take a look at that first example. On this problem, we look and we see we got 5x plus 2y equals 16, and we have 3x minus 4y equals 20. We need to do elimination, and we know the rule from last section was that we need to have the opposite numbers in front of the same variable. Right now we've got 3 and 5, and 2 and negative 4. Our best bet is going to be, for these problems, is to multiply one or both of the equations and then do elimination. If we look at this example, there is going to be an easier variable to eliminate this time. And this time, you look and you say, you look at the factors, 3 and 5. Can I multiply 3 by something and get 5? No. But I got 2 and 4. Can I multiply 2 by something and get 4? I can. What are we going to multiply 2 by to get 4? It's 2. So we're going to multiply the top equation by 2. And some of you are saying, well, Mr. Nickerson, you must be completely blind. That says negative 4. It's okay. We're just saying 2 times 2 gives me positive 4 because we want a positive and a negative. So we're going to multiply the top equation by 2. So that's going to result in 10x plus 4y equals 32. The bottom equation hasn't changed. And now we can eliminate 13x, so those cancel. 52, 13 divided by 2 here. So 52 divided by 13 will give us plain old 4. When we go to find our y value, use one of the originals. Not only are the numbers smaller, but if you made a sign error, it would show up. So let's use one of the originals. 5 times 4 plus 2y equals 16. So 20 plus 2y equals 16 minus the 20. 2y equals negative 4. Divide by 2, and we get y is equal to negative 2. Now that we have our answer, check it in both originals. You got to check them in both. So 5 times 4 plus 2 times negative 2 equals 16. 20 minus 4 equals 16. Would you look at that? Checks out. Let's check the second. So 3 times 4, 12. A negative times a negative is a positive 8. 20. And sure enough, 20 equals 20. We just successfully did our first elimination problem where we had to multiply first. Alright, let's take a look at example 2. On example 2, I chose to eliminate my y. And the reason being is that I saw that a 1 in front, so I know that I can multiply 1 by 11 and get 11. But at the same time, I need opposite signs. So when I multiplied by negative 11, it resulted in negative 22x minus 11y equals 99. After that, I was able to find my x. So negative 18x equals 108, divide by negative 18, and then get x equals 6. Following that, I went down here and I plugged in negative 6 for x, found my y, and got positive 3. And then finally, the last part, but very important part, the check and check both of them out. Sure enough, they both check, and there's example 2. All right, let's take a look at example 3. We start off by saying, what can we eliminate? Well, we've got 2x minus 3y equals 6, and we've got 7x plus 4y equals negative 8. From that problem, right now, we know we're unable to just do plain old elimination, so we're going to have to multiply. So now we investigate some more. We say, well, 2 times, is there a number that we can multiply by 2 and get 7? No. Is there a number we can multiply a negative 3 by and get 4? No. So this time, instead of multiplying by one equation, we're going to have to multiply by 2. For right now, it's your choice on which you want to eliminate, but the reason I would choose to eliminate the y's this time is that they already have the opposite sign set up for us. So since they have already signs set up, I'm going to choose to eliminate my y on this problem. And now we need to think, really using a concept you learned a long time ago, what's the smallest number that 3 and 4 both multiply to? Or what's known as their least common multiple? Well, that number would be 12. What do you have to multiply the top equation by to get 12? Well, I got to multiply that 3 by 4. What do I got to multiply the 4 by on the bottom? The 3. So I multiply both equations. 8x minus 12y equals 24. 21x plus 12y equals negative 24. You need to make sure you remember to multiply every part of each equation. So this time, multiplying the 4 to each term, and then multiplying the 3 to all those as well. Now we're all set to eliminate. Okay, so now we're all set to eliminate. So we get 29x. Those eliminate. And 0. A lot of people get confused on these problems. They say, why am I off? You did this completely correct. We divide by 29, and we know that 0 divided by a number is 0. Now that we have that answer, when you go to plug into one of the original equations. I'll choose the top one. 2 times 0 minus 3y equals 6. Well, we know 2 times 0 is 0, so negative 3y equals 6. So I get dividing and negative 2. And finally, when you check, make sure you check the 2 originals. So 2 times 0, 0. Plus 6 equals 6. Sure does. Check our second. 7 times 0 plus 4 times negative 2 equals negative 8. And negative 8 equals negative 8. All right, let's take a look at example 4. I started off by choosing which variable I wanted to eliminate, and I looked and I saw the positive and the negative on y. I saw that x had 2 and 3, so there was no number I could multiply without getting the fractions, so what I did was I eliminated my y. So I started off by multiplying the top equation by 3 and the bottom equation by 4. After that, if you look to the right a little bit, there is my new resulting equations. From here, from those 2 equations right there, it's just solving a system by elimination. So I added, I got 17x equals negative 51, divided and got x equals negative 3. After that, going a little bit to the left here, I plugged in to my my top equation, 3 times negative 3 plus 4y equals negative 25, solved and got y equals negative 4. And finally the last part, the check, as you can see, check them out, and sure enough they work. Alright, so I started off example 5 and I figured out what do I want to eliminate. Then y had a positive, negative again, so I chose the y. You can still choose the x. You just got to make sure we multiply one of those by a negative and still make it to 12. But chose the y, and you can see I just typed in that equation 8x plus 14y equals 20, and 21x minus 14y equals negative 49. Did my addition, got 29x equals negative 29, and got x equals negative 1. came over here to the left a little bit, and then found out my y value. I plugged into my top equation. I got y was 2. And then finally, at the bottom here, we've got our check work, and you can see that they both check out. Would you look at that? All right, looking at the final example, example 6, you start off and say, what can I eliminate? Well, hopefully you chose the y on this one, because if you chose the y, you would see that it's already negative 2 and 8, and this time I only have to multiply one equation if I choose my y. If I chose my x, I just have to multiply 2. So if you multiply the top equation by 4, you get the resulting equation here of 20x minus 8y equals negative 60, and 3x plus 8y equals 37. We do our addition. 23x equals negative 23. Divide, and you get x is negative 1. Following that, I go a little bit here to the right, and you can see I just plug into my second equation, my second original equation, and I find out that y equals 5. And finally, last but certainly not least, is the checks. Check them in both originals, and they do work out. That concludes today's lesson. See you later.